Mathematics made easy. Squared numbers and square roots.
An exponent is a small number placed above and to the right of a base number. It shows how many times to multiply the base by itself. When our exponent is the number 2, we refer to the base number as being squared. A common misconception in dealing with squared numbers and other exponents is that the base number is multiplied by the exponent. This is false. Our exponent simply tells us how many times to multiply the base number by itself. For this demonstration, we will use the number 2 to the 8th power. We will cover this in more depth in future videos. If we have the number 2 to the 8th power, we do not multiply 2 times 8. This would be incorrect. Instead, if we have the number 2 to the 8th power, we would multiply 2 by itself 8 times. This is another example of understanding what 2 to the 8th power means. 2 times 2, 4. Times 2, 8. Times 2, 16. Times 2, 32. Times 2, 64. Times 2, 128. Times 2, 256. We will use the same process in understanding all exponents. A squared number is represented by the exponent number 2. Examples of squared numbers are 2 squared, 8 squared, and 12 squared. To the right, you will notice 3 squared numbers. They are 2 squared, 8 squared, and 12 squared. What we call our base number is highlighted with the color red. In this example, our base numbers are 2, 8, and 12. Our exponent is highlighted with the color yellow. In this example, our exponent is the number 2, making our base number squared. Some examples are 2 squared equals 4. This is the same as saying 2 times 2 equals 4. 8 squared equals 64. This is the same as saying 8 times 8 equals 64. 12 squared equals 144. This is the same as saying 12 times 12 equals 144. A square root is just the inverse operation of squared numbers. A square root is written using this symbol, highlighted in the color yellow. Below are some examples of perfect squares. If we wanted to write the square root of 4 equals, it would look like this. The square root of 4 equals 2. If we wanted to write the square root of 64 equals, it would look like this. The square root of 64 equals 8. If we wanted to write the square root of 144 equals, it would look like this. The square root of 144 equals 12. If we want to know the square root of the number 144, we must find out what number multiplied by itself equals 144. We know that 12 times 12 equals 144, which is also known as 12 squared. This means that the number 12 is the square root of the number 144. Therefore, the square root of 144 equals 12. If we want to know the square root of the number 64, we must find out what number multiplied by itself equals 64. We know that 8 times 8 equals 64, which is also known as 8 squared. This means that the number 8 is the square root of the number 64. Therefore, the square root of 64 equals 8. If we want to know the square root of the number 4, we must find out what number multiplied by itself equals 4. We know that 2 times 2 equals 4, which is also known as 2 squared. This means that the number 2 is the square root of the number 4. Therefore, the square root of 4 equals 2. Perfect squares versus irrational numbers. Perfect squares are square roots that have no decimal point and are whole numbers. Perfect squares are also like finding pairs of items. For example, if you have 4 chopsticks, you can make 2 pair because 2 times 2 equals 4, also known as 2 squared. Perfect squares versus irrational numbers. Irrational numbers are one of the messier areas of mathematics, but they are an important one. A square root that has a decimal and cannot be expressed as a simple fraction is called an irrational number. For example, the square root of 2 is approximately 1.414, and it goes on forever without repeating. Irrational numbers are defined as real numbers that cannot be expressed as a simple fraction or ratio of 2 integers. Perfect squares versus irrational numbers. Say there are 2 fresh apple pies being shared between 2 people. No problem. Each person gets 1 whole pie. But say 3 people want to share 2 fresh apple pies. These 2 fresh apple pies can never be shared evenly between 3 people. If you tried to split the 2 fresh apple pies between 3 people perfectly, you would be slicing the pies into smaller and smaller pieces indefinitely, and you could never mathematically obtain a perfect share.